What if black holes weren't the final stop? What if, instead of devouring everything in their path, they returned something transformed, reconfigured, maybe even carrying the fingerprints of the universe itself? For over a century, we've treated black holes as the ultimate one-way doors, mysterious regions where gravity grows so ferocious that nothing, not even light, can escape. But now something has changed. Something has been seen, something that defies the very laws we've long considered unbreakable. And it came from the most distant reaches of space, captured by a telescope that is already rewriting the story of the cosmos, the James Webb Space Telescope. In the cold silence of space, light from billions of years ago drifts toward us, revealing echoes of galaxies that existed long before Earth was born. And in one such distant galaxy, so far that its light began its journey before the first complex life emerged on this planet, JWST saw something extraordinary. It wasn't just another image of cosmic chaos. It was order, purpose, structure. A plume of matter that seemed to defy every expectation of what a black hole should be capable of. Something was coming out. This wasn't science fiction. This wasn't theory. This was light. Data. Real. A narrow, concentrated outflow of energetic particles, clearly shaped and defined, emerged from the vicinity of a black hole, not from the surrounding galaxy, not from a distant star, but from deep within a region we once thought no signal could ever return from. It wasn't a chaotic explosion or a random jet flaring wildly into space. It was clean, focused, like a whisper piercing the silence from a place that had no voice. The first images arrived at Earth quietly, buried within terabytes of other observations. But once noticed, they sent ripples through the astrophysics community. Scientists stared at their monitors, jaws slack, minds racing. This was not a typical relativistic jet. Those we know well. Jets launched from the poles of spinning black holes due to magnetic field interactions in the accretion disk. Those are violent, unpredictable, often messy. But what JWST captured, it was none of those things. It had curvature, graceful, gravitationally sculpted curvature, as though its path had been bent, not flung. The arc traced in that plume hinted at extraordinary forces, not of chaos but of design. And in its spectral fingerprint, something even more perplexing. Heavy elements, iron, gold, thorium, elements that are usually forged in the hearts of dying stars or in the immense pressure of stellar collisions. But here they were, escaping from the mouth of a black hole. The structure of the outflow, the complexity of its emission, the sheer improbability of its existence. None of it made sense. And yet there it was. Measured. Real. The implications hit like a tidal wave. Because if matter is escaping, or being reshaped and expelled, then the black hole is not an ending. It is a process, a transformation engine. A region of space where physics doesn't stop but instead, evolves. And that changes everything. We've long known black holes are messy eaters. Their immense gravity pulls in gas and dust, forms glowing disks of matter spiraling inward, and sometimes ejects energy in massive jets perpendicular to those disks. But this was different. This wasn't ejected from a swirling disk, flung sideways by tangled magnetic fields. This looked like it came from within. Not the singularity itself, no one's suggesting that, but from right outside the event horizon where quantum mechanics begins to argue with general relativity and reality becomes flexible. The James Webb Space Telescope, built with a sensitivity unmatched in human history, was able to peer into the infrared shadows of this distant black hole and extract not just light, but structure within the light. Spectral structures that whispered of atomic arrangements far too deliberate to be random. Subatomic signatures with patterns more akin to information than raw chaos. And this, more than anything, has sent theorists into uncharted waters. Because suddenly, speculative frameworks long considered fringe, theoretical playgrounds of those chasing ghosts, have new life. Concepts like Hawking radiation expressing itself in macroscopic flows. Wormhole-like mechanisms that could ferry energy out of spacetime. Quantum tunneling events that allow particles to escape gravitational imprisonment under the right conditions. It's all back on the table. Even more tantalizing, the possibility that black holes are not strictly black. That they may, under certain conditions, act as cosmic editors, compressing matter, distilling it, and releasing it in new organized configurations. As if space itself is not just swallowing information but processing it. And here's where the story grows stranger still. Inside that outflow, inside that plume that stretched across light years, was embedded a strange consistency. Not just in matter but in modulation. The frequency of the infrared light was subtly pulsing. A rhythm. A beat. Not random. Not easily explained. Scientists initially assumed it might be interference from the host galaxy or the telescope itself. But no. The signal remained consistent across multiple filters, multiple calibrations. It was real. A rhythm like a breath. Or a pulse. And in that rhythm was complexity. A kind of encoded layering that some compared to the structure of musical harmonics. A bass tone and then overtones stacked in symmetrical ratios. Natural yet impossible. As if the matter wasn't just being ejected, it was being arranged. This isn't just astrophysics anymore. This borders on something more profound, information science, quantum computation, even the early whispers of consciousness at the edge of the void. If that sounds far-fetched, it is. And yet here we are. In 2025, looking at infrared fingerprints from a galaxy billions of years away, wondering if the most destructive forces in the universe might also be its most creative. No one's claiming black holes are intelligent. But the processes near their boundaries, the dance of particles, waves, fields, are beginning to look less like chaos and more like choreography. There's an elegance emerging from the noise, a signature hidden in the fury. And it forces a difficult question. What is a black hole really? For a century we've treated it as an endpoint. A place where time stops. Where all paths converge and vanish. But what if that's not the end of the story? What if a black hole isn't a cul-de-sac of the universe, but a valve? A converter? What if, under certain conditions, the extreme physics near its edge generate not destruction, but creation? That's where this discovery takes us. Into a realm where quantum foam and curved space intermingle in unpredictable ways. Where gravity itself may become a conduit. And where energy, structured, layered, meaningful energy, can climb out from the deepest well in the universe. We don't know how. We don't know why. But we've seen it. And now everything must change. The textbooks will not be rewritten overnight. The data will take years to fully analyze. But already the foundations of astrophysics are shaking. Because JWST didn't just capture an image, it captured a question. A new kind of question. One that our current models don't know how to answer. Is it possible we're witnessing the first hints of how black holes communicate with the rest of the universe? Not with sound. Not with intent. But with rhythm, light, and pattern? Could black holes be broadcasting? Could the universe, in its deepest, darkest corners, be less silent than we thought? For now we can only watch. And wonder. The plume stretches outward, a glowing trail from an impossible source. Matter reshaped. Energy reborn. Somewhere, in a galaxy far older than our own, a black hole has whispered. And James Webb was listening. He whispers says, "I am not what you think I am." What followed next was nothing short of breathtaking. The James Webb Space Telescope, with its unmatched infrared vision, stared deep into the very heart of the void, where most instruments would simply falter. Unlike traditional optical telescopes that get lost in the blinding brilliance of high-energy emissions or obscured by the thick blankets of cosmic dust, Webb sliced through the darkness like a scalpel. Layer by layer, it peeled back the fabric of interstellar shadow and revealed something utterly unprecedented. An actual plume emerging from a region long believed to be one way only. It wasn't a random flicker. It was a consistent, structured flow, a trail of material being ejected from a black hole's event horizon, captured across multiple frames, showing direction, texture, and persistence. The data didn't just hint at it, it practically shouted. And as those images were analyzed, refined, and confirmed by auxiliary instruments, X-ray telescopes orbiting Earth, ground-based radio arrays stretching across continents, the evidence only grew more concrete. The phenomenon was real. This wasn't noise. It wasn't gravitational lensing playing tricks. It was an actual emission event happening in a place where emissions shouldn't happen. Something, somehow, was getting out. That alone would have been revolutionary. But what made this even more haunting, even more exhilarating, was the implication. If something was coming out, if matter, or radiation, or encoded particles were making their way back into the observable universe, then maybe, just maybe, information wasn't being erased after all. That single thread led to the unraveling of one of the deepest mysteries in theoretical physics, the information paradox. For decades, scientists have been locked in an uneasy truce between Einstein's general relativity, which insists that nothing escapes a black hole, and quantum mechanics, which demands that information can never truly be lost. The two frameworks, powerful on their own, have always been at odds when it comes to the singularity. Now, with JWST's data in hand, the idea that black holes might actually emit something meaningful, perhaps even something that carries fingerprints of what fell in, tilts the balance in a whole new direction. What if black holes are not cosmic shredders of information, but sophisticated encoders? What if they swallow complexity and release it back in a different form over time, under extreme conditions? The metaphor shifted instantly. No longer just the universe's garbage disposals, black holes now started to resemble vaults. Gatekeepers, storytellers. Their silence, perhaps, was never emptiness, it was language we hadn't yet learned to interpret. This newly observed outflow wasn't just particles, it was potential. A possible channel through which the universe might communicate with itself. It echoed across dimensions, scientific, philosophical, existential. Suddenly, everything we thought we understood about time, entropy, and causality stood up and began to stretch in unfamiliar directions. This wasn't just a crack in the wall. It was the beginning of a doorway. If such emissions are real, and if they can be studied, decoded, or even predicted, then we may be on the cusp of integrating two of physics' greatest rival theories into one harmonious framework. A unified theory. A true bridge between the deterministic elegance of relativity and the probabilistic chaos of the quantum world. And it's happening not in laboratories or chalkboards, but billions of light years away, in the hearts of dead stars, with tools we only recently finished assembling. But the implications don't stop at physics. They ripple outward, tugging at the very roots of human curiosity. For generations, black holes have stood as metaphors for finality, for oblivion, for the unknown beyond return. Now that metaphor is evolving. If even black holes can give something back, then nothing is ever truly lost. Not energy. Not matter. Not even meaning. There is something deeply poetic in that idea, that the darkest places in the cosmos might still have stories to tell. And while researchers are already racing to build theoretical scaffolding around this new observation, crafting simulations and models to explain how such emissions could occur, another conversation is beginning to unfold, a philosophical one. For if black holes are capable of expressing something outward, then what else have we misinterpreted? What other assumptions do we carry unquestioned, simply because our instruments weren't sharp enough or our minds weren't ready? Already, speculation is swirling like stardust. Could high-energy particles we detect on Earth, cosmic rays with mysterious trajectories and unexplained intensities, actually be linked to similar black hole outflows? Could some of the gamma-ray bursts we've long attributed to collapsing stars be, in part, emissions escaping the grip of singularities? Could magnetar flares or fast radio bursts be echoes of this same process, misunderstood only because we lacked context? Suddenly, decades of observational data are being re-evaluated with fresh eyes. New simulations are being run. Entire theses are being rewritten. The cosmos just gave us a new puzzle piece and it doesn't fit where we thought it would. And that's the beauty of it. Science doesn't just march forward, it tumbles, it rewinds, it leaps sideways. One discovery like this can rewrite the questions we thought we were supposed to be asking. And at the center of it all is JWST, orbiting 1,000,000 miles from Earth, a sentinel watching the deep with golden eyes, unlocking secrets from a time before light had names. More discoveries will come. That much is certain. JWST is only in the early chapters of its mission. Every day it observes, it challenges the limits of what we believed was possible. It stares into the heart of distant galaxies, peers beneath the veils of exoplanet atmospheres, and now, astonishingly, it has looked at a black hole and seen not death but process. Not silence but message. And as this insight echoes through scientific circles and space agencies worldwide, it also raises the urgency of further exploration. We now know that there are regions of space producing activity we never anticipated. But how many more remain unseen simply because we lack the proper tools to perceive them? The case for more advanced telescopes, higher resolution observatories, and broader spectrums of detection has never been stronger. JWST has ignited something profound, and now humanity finds itself at a new threshold, facing a cosmos that's not just vast but expressive. To look at a black hole and find a message is to confront the idea that the universe is not indifferent, that it has structure, rules, and maybe even rhythm. And to decode that rhythm is to understand ourselves just a little bit more, because we are, after all, made of the same matter that collapses into stars, explodes in supernovae, and swirls into the gravity wells we call black holes. We are children of entropy. But now, perhaps, we are also students of renewal. This moment in science is not just an incremental advance. It is a cultural one. It's a spark in our shared narrative about who we are and what's possible. For millennia, we've looked up at the stars and asked what lies beyond. Now, for the first time, something from beyond may be answering back, not with words but with patterns of light and energy, carved by gravity and flung across spacetime into our waiting sensors. So as the JWST continues to scan the skies, we find ourselves not at the end of discovery, but at its true beginning. The boundaries we once feared may not be limits, they might be invitations. Black holes, once symbols of cosmic termination, now hint at cycles, at the return of the lost, at the endurance of form. They are not the universe's period. They are its ellipses. And if that's true, if this is just the beginning of a new era in black hole physics and interstellar communication, then humanity stands on the edge of something even more profound than technology or knowledge. We stand on the edge of understanding what the universe has been trying to say all along.